Hello, everyone. You are welcome to today's lesson. Today's lesson is going to be lesson 2 on the topic vectors. In lesson 1, if you remember, we looked at the basic definition of a vector quantity. Okay, we looked at the algebra of vectors, how to add and subtract two or more vectors, how to multiply a vector by a scalar, and we also looked at two main forms of representing vectors. Apart from the fact that we looked at two special types of vectors, free vectors and position word vectors. Today's lesson is going to be a continuation. I think we also did, yes, we also did finding the magnitude of what of vectors in lesson 1. Okay, in lesson 2, we are going to pick out from where we left off in lesson 1. Okay, so we are going to look at various or other types of what vectors with their special features or characteristics. Then after that, okay, we will look at how to make use of some other concepts related to okay vectors, especially called mass vectors. So once again, as always, stick and stay with me as we enjoy the class, and I'll rely on you for an interactive okay session. All right, just as you can see on your screens. Okay, we have types of vectors. And the first type of vectors that we are going to look at will be what we call the null or zero, okay, vectors. Null or zero vectors, or null or zero vector, okay, if I want to look at it to be singular. So this is a vector with a magnitude of 0. Okay, so you can see that the name itself is trying to tell you something about what I said in terms of the definition. So the definition makes use of what? The 0, but the 0 is relative to the magnitude. So like I said, usually when it comes to vectors, okay, the names of vectors come from, okay, the magnitude or the vector's what magnitude. So if the vector has a magnitude of 0, we give the name of the vector or we label the vector a 0 what vector. 0 we all know is the same as now. Okay, so take note. So it has only direction and not what magnitude. Okay, when we say, okay, that doesn't mean a 0 vector is not a vector, please. Okay, take notes. Because remember we said in our definition of vectors, we said a vector is any quantity that has both, okay, magnitude and what, and direction. Okay, if I say that it doesn't have magnitude, that doesn't mean, okay, you can't find its magnitude. It only means that the magnitude will be 0. Am I clear?
Yes.
Okay, that's not to say that the magnitude doesn't what exist. So all components equal to 0. All the components. So you know that we said vectors, one form of representing vectors in the column or component form. Okay, so with this one, if you say that all the components are 0, then it means S component will be equal to 0, Y component will be equal to 0. And it is denoted by, okay, you know that this is a small o, okay, bold. Okay, small o what? In capital, did I say in capital? In bold. So take note, when it's in bold and it's small, we know that we are dealing with a special notation for a position vector. So in this case, I can also say, because here we are saying that it is O, small letter O. When you are writing it, you know you will use that term that small letter O is equal to, and we said it will be a vector with all the entries, all the components being 0. So it will be 0, 0 in terms of column. Is my point well made?
Yes.
Okay,
Please come
so
again.
I said, okay, in vectors, you know that we said vectors, we have two main forms of representing vectors, magnitude bearing and the column form. Okay, even apart from that, okay, we said we have free vectors and position vectors. However, in our last meeting, we learned that position vectors, they have special notations. So if you have a position vector, and we said all position vectors, they will take their source or origin from what? From 0. So if I have OA, remember we said, okay, the name of the vector in terms of its special notation will come from the terminal letter, which is A. This is the initial letter, this is the final or terminal letter. So in this case, this is equal to special notation will be A. In print, it will be bold, but when you are writing it, you don't write it in bold, but you use the tilde to bring out the, what do you call, the vector nature. So in the same way, you can see that here indirectly, whatever that you see here must be regarded as what you see in print. So in print, you can see that this is bold O. So we are using O to represent what? A zero vector. Okay, O, and a small o, and it's bold. So if I am writing it, I'll write a small o. I cannot bold it, I will not bold it, but I'll bring out the vector nature by using the tilde. And if you look at what we have here, we said this will be a vector with all the components being 0, equal to 0. So every vector will have the component x, y. So if I'm saying that my component will be 0, then it means x will be 0, y will be 0. So that gives us what we have here. Is it clear now?
Yes, please.
Okay, very good. All right. Okay, so now let's look at, okay, the unit vector, if that's okay. All right, so this is a unit vector. So a unit vector, just as I said, usually vectors are labeled based on the size of its magnitude. Okay, so if you said a vector with a magnitude of 0 is a 0 vector or a null vector, then a unit vector basically will be a vector with a magnitude of 1. I hope you are with me.
Yes, please.
Okay, all right. So take note. Okay, so remember we said if you are dealing with a 0 vector, all the entries should be 0. If you are dealing with a unit vector in terms of component form, what do you think, okay, will be the size, the values of all the components? Please be careful you don't fall into this trap. It's a trap, I'm warning you. Okay, so what do you think, okay, will be the entries? Hello? Is it because I said it's a trap? You are afraid. Don't worry. Okay, Prof. Amma.
The stack one, please. I'm trying.
Okay.
And we said what would be the entries in the component form. I think to be the same because it said the component form is the same as the column form.
Oh, no, you don't get that. I want the values of the x and y. Here we said that for 0, the values of the x and y will be 0, 0. Okay, so for the units, what will be the values of what x and y? That's what I mean. So if I have maybe a unit vector, okay, so I have a unit vector with the entries. I need the entries. So entries will be x, y. What do you think will be the size of what? Of x? Okay, that's the value of x and the value of y. That's what I'm looking for. Is my question clear now?
Oh,
Okay, 0, we said it will be
yes.
0, 0. So 1, what do you think 1 of which is the unit will be?
1, 1.
Ah, you are caught in the web. Okay, so please take note. Okay, it will not be 1, 1. Let's see why it is not 1, 1. Then I will tell you, okay, the right one. So 1, 1. Remember we said, okay, we all know how to find the magnitude of a vector, right? From our previous lesson. Okay, if you
Yes.
don't know, okay, so in this case, if did I hear no?
No, I said yes, please.
Okay, all right. Okay, so now let's see. Let's look at how the magnitude of this vector and see whether it will give us a magnitude of 0. If you are finding this, the magnitude will be root of. Remember, magnitude will be x square, x component squared. So the x component here is 0, 0 squared. Okay, plus the y component also squared, so 0 squared, which in effect will give us what root of 0 plus 0, which will give us what root of 0, which is also what 0. Is that not it? So
Yes. Yeah.
indeed, the vector that we stated there has a magnitude of 0. Now let's go and look at what you just said, that the entries will be what? 1, 1. So let's see. So the magnitude of this vector will be 1 squared, which is the x component, okay, squared plus what? 1 squared. Okay, which in effect will give us root of 1 squared we know is 1 plus 1 squared, which is 1, which will give us root of 2. Okay, obviously we know root of 2 is not 1. So it means we can't take this as what? A unit vector because its magnitude is not giving us 1 but root of 2. Please, I hope you are with me. Those of you who thought the entries would be 1, 1. Are you with me now?
Yes.
Okay, so take notes. The entries will be, we have two special ones. Okay, so the special ones will be what I'm going to write. Okay, you can have the S component, okay, being 1 and the Y component being 0. Or, okay, you can have what? The S component being 0 and the Y component being 1. These are the two special unit vectors that you should know of. So we have other what unit what vectors. Is my point well made, my professors?
Yes, please.
Yes, please.
Okay, Prof. Walali.
Yes, sir, please, I have a question.
Okay, don't worry, I
So
also have
please,
an answer.
so please, why is it that in the statement you didn't just put 2 units, like the first one, 0, 0, so that you just explain it, but then you wrote 1, and now the final answer is 2.
Which one?
The unit vector.
Uh-huh.
Why isn't it a vector whose magnitude, okay, is 1 unit, is often used to indicate direction? Like, why isn't it 2?
Why isn't it what to the magnitude?
Yes,
The
as the
magnitude
answer here.
as this answer.
Yes, please.
No, okay, if I get you right, I'm going to explain. If I'm going to explain the way I got you. If I got you wrong, come again. Is that okay?
Yes, please.
All right. Okay, so remember we said vectors are usually named, okay, based on its magnitude. So if you have a unit vector, then it means that vector that you are going, every vector will have a component. So the component, the S component, Y component will be values. So if you put the values there and you find its magnitude, which we did in our previous lesson, lesson 1, okay, that magnitude that you are going to find should give us 1 unit. So you said a vector whose magnitude is 1 unit, okay, and is often used to indicate what direction will be a vector which we call what? A unit vector. However, remember I said, if you look at the definition of what a null vector or a zero vector, okay, and how we're able to get the entries, if you don't take care, remember we said a null vector, all the entries will be 0. And 0 is coming from the fact that we have a 0 vector, so everything will be 0. So if you don't take care and you come to the entries for the unit vector, you might also think that the unit vector, the entries, all of them should be 1. But if the entries, all of them are 1, remember I told you, if all of them, then if you are finding the magnitude of this, okay, when it is 1, 1, if you are finding the magnitude, this is how you find the magnitude. So it will be root of 1 squared plus 1 squared, which if you continue, you end up getting root of 2. So if you have a vector which has component S component 1, Y component 1, its magnitude is rather root of 2 units. Okay, so once it has a magnitude of root of 2 units, we cannot call this vector here with entries 1, 1 to be a unit vector because its magnitude is not 1, it's not units. You get the point?
Please come again.
Okay, all right. Basically, we said any vector whose magnitude is 1 is a unit vector. So if you give any vector and you find the magnitude and the magnitude is not 1, then it means it ceases to be a unit vector. Okay, if I give you, assuming I give you a vector AP, okay, or let me even use AB, is equal to 1, 1. Prof. Olali, how would you find the magnitude of this vector? What would be if you are finding the magnitude of the vector AB? Okay, this will be equal to root of, is it not 1 squared? Okay, plus 1 squared. Are you with me, Prof. Olali?
Yes, please.
Okay, which in effect will give us what? Root of 1 plus 1, because 1 squared is 1 plus 1 squared, which is also 1, which will give us root of 2. Okay, then your unit, is that clear? Okay, so a vector with entries 1, 1, what is its magnitude? What is the magnitude, my prof?
Please come again.
A vector with the entries 1, 1, with the component 1, 1, what will be its magnitude based on what we've done?
2 units.
It's not 2 units. It's root of 2. Or you can't see the roots. Only root in your fire now, so you don't want to mention roots. So it's root of 2. Can you see that? It's not 2. It's root
Yes.
of 2. So it's root of 2 units, which is different from 2 units.
Okay.
You get it? So once the magnitude didn't give us 1 unit, it means any vector with the entries 1, 1 cannot be regarded as a unit vector. Is that clear?
Yes, please.
Okay, so I guess you are
Thank you.
sorted now.
Yes, please.
Okay, great. All right, now let's come to the one that I said, okay, will be units, the special ones. Let's verify indeed if that will give us a unit vector because of its magnitude. So if I have a vector with entries 1, 0, then I'm finding it what magnitude, the first one. We are going to get what? Root of our s component squared. S component is 1, so 1 squared, plus what? Y component squared. Y component is 0, so 0 squared. Okay, which in effect will give us, and please take note, I'm writing more than an equal to on the same line because here it's not a main work, it's a rough work. If it's a main work, I would have brought, okay, first equal to will be a second equal to will come down. You know how I do my presentation. So don't say maybe, or don't relate whatever that I have there to your main presentation. It's a rough work. So this will give us root of 1 squared, which is 1, plus 0 squared, which is 0, which will give us root of 1. And root of 1 is the same as 1. So you have 1 unit. So it means indeed it's a unit vector. Do you agree? Please, are you with me?
Yes, please.
Okay, so try the second one too and see the all situation. Okay, so that one will give us root of 0 squared, which is 0, root of 0 squared plus 1 squared. So that will also give us 0 plus 1, which is root of 1, which will give us 1. Am I not it?
Yes, please.
Okay, very good. So if that is the case, then you should know that these two are special. And I said, just like I said, these are two special ones that you can easily recall. We have other, okay, unit vectors. And the relative math students, remember we did, okay, unit vectors in the direction of another vector. And we said, okay, in that case, you had other vectors that when you find its magnitude to give you one. Okay, but these are the two basic ones that everyone should know. Okay, so thank you very much if you are following. Okay, so on this note, I am going to move on to the next slide. Can I move on to the next one and look at our next type?
Yes.
Okay, all
Please.
right. So let's move on to the next one. So the next type, still on types, will be equal vectors. The name itself, okay, should connote something, should tell you what something. So two vectors with the same magnitude and direction, regardless of their initial points. Two vectors, okay, with the same magnitude and direction regardless of their initial point. So whenever you have two vectors, they are in the same direction and they have the same magnitude, then you can say that the two vectors are equal. Okay, however, for computational purposes, okay, we need to know what we have in bullets here. So if two vectors, and I'm using special vectors, position vectors, the vector A with the, once I mention two vectors, then you should know that, okay, the component will have subs. At normal circumstances, if it's only one vector, it will be X then Y. But because I have two, it will be X sub 1, Y sub 1, that's the S and Y component respectively of the A vector. Okay, then the vector B, the position vector B, okay, will also have X sub 2, Y sub 2. Okay, are equal if corresponding components are equal. So this vector, its S component is X sub 1. This one, its S component is X sub 2. So for them to be equal, okay, the X sub 1 should be equal to X sub 2, and Y sub 1 should be equal to Y sub 2. So the corresponding component must be equal before you can say that they are equal. Just like if you are dealing with equal points. Remember I told you, if you have a fair idea of coordinate geometry points, okay, you should be able to appreciate all the concepts, okay, or most of the concepts related to vectors. So when 2 points are equal, the coordinates must be, corresponding coordinates must be the same. X coordinate should be equal, Y coordinate should be equal. Other than that, they are not equal points. In the same way, two vectors will be equal when X components are equal and Y components are equal. Is my point well made?
Yes.
Okay, and you can see that
Yes.
here I use a special notation. Okay, so it means the vectors that I use, okay, to compare whether they are equal or not, or bring out the equality of what of vectors were special vectors, position vectors. However, I can have three vectors. So I can have a vector A, B, also in the column or component for maybe okay x sub 1, y sub 1, and another vector, let me use CD, okay, also with the component x sub 2, y sub 2. Okay, so for them to be equal, so if vector AB, okay, is equal to vector CD, then this implies that vector AB is what x sub 1, y sub 1, and should be equal to vector CD, and that is what x sub 2, y sub 2. And this will only mean that x sub 1 should be equal to x sub 2, and what y sub 1 should be equal to y sub 2. So this should be equal to this should be equal to that before you can say that they are equal. Afa, is the explanation okay, my professors?
Yes.
Yes, please. But sir,
Okay.
please, can you use numbers?
Yes, you come to numbers. You know that usually I start with general. When you get to general, then we move on to particulars where you are using numbers. Is that okay? So those of you in love with numbers, don't worry. Okay, you see numbers pretty soon. I hope you are with me.
Yes, please.
Okay, or
Yes.
better still, I can also say maybe I have a vector PQ. Okay, to be equal to okay 3, 2. Okay, and I have a vector XY to be equal to maybe okay AB. Under what circumstance will these two vectors be, or what condition will these two vectors be equal? Under what condition? Or when will these two vectors be equal? Professors, are you there? This will take us to what we are going to. If you get this, then we can move on to our next slide, which will be dealing with worked examples. Okay, so under what condition? Or you think the question is too trivial, that's why you don't want to answer? Okay. Oh, someone, my professors, where are you? Oh, this one, there's no trick. Oh, there is no trick. Okay, there's no trap. Okay, it's just a straightforward, direct question. So put up your hand and answer. Don't be afraid to be ensnared by any traps. There are no traps here. Okay, so, okay, all right. I'm also part of the class, so I am going to answer if you don't want to talk. Okay, so for P vector PQ to be equal to vector XY, A should be equal to 3 and B should be equal to 2. That's all. Other than that, they are not equal. You get the point? That's the only situation that they could be equal. Afa,
Please come again.
okay, I said if you want to use basically the definition. Okay, so if, let me put it this way, if, okay, A vector PQ is equal to vector XY, this implies that, okay, or then vector PQ, which is 3, 2, should be equal to vector XY, which is AB. Okay, so at this note, we know that A should be equal to 3 and what B should be equal to 2. That's the only condition or situation that the two vectors will be equal. But I looked at this and said the values of the A and B straight away. But this is where that idea comes from. How I got that. Is that okay?
Yes.
Okay, so if I have a vector CD, okay, with entries maybe for let me use P, and I have a vector, let me use, okay, ST, okay, with the entries Q, -1. What do you think will be the values of P and what? And Q, this is Q, for the two vectors to be equal? If you get it, then we can move on to the next slide. Then I know that going forward, my work is going to be very easy. What would be the values of P and Q? Just look at it and tell me. You should be able to do so. Oh, my professors, are you okay? Are you here? What is happening to my professors this afternoon? Are you people hungry?
Yes.
Okay, then
Yes,
please,
please.
you should all send me your location, then I'll get you something.
Yes, please.
Okay, all right. So what will be the values of P and Q? Okay, Prof. Samuela.
At least I'm trying.
Okay,
P will be -1 and Q will be 4.
perfect. Because for them to be equal, corresponding components should be equal. So it means that Q here should be equal to 4 and P should be equal to what? -1. S component being equal, Y component being equal, as simple as that. So on that note, okay, we can move on to whatever we are going to do here. Okay, we are going to build the foundation. Okay, build on the foundation that I just laid. All right, so now let's look at the following questions. Work example 1. Okay, so given that vector AB, which is a free vector, okay, you know is equal to 3, 4. Ella, I won't mind you. I thought you sent me a Google location. If you say Numba, the Numba is too big. Then it means you don't want me to locate you indirectly. All right. Okay, so BC, vector BC is 8, -2. Vector PQ, okay, with the coordinate, so did I say coordinate? Forgive me. Component. And ST with the component XY. Find the values of X and Y if, okay, with the following condition. So this is all that we are going to do. It's nothing difficult. Remember, when you read questions, you make it a point to underline salient parts. So for me, I will underline maybe values of X and Y. So until I state the values of X and Y, I'm not done. Okay, all right. So now what do you do after that? You write solution, then you extract all that you will need in the question to have the solution fully provided. Okay, so at this point, I will extract. Do I have any major question number? No. Okay, so I can extract this with no major question number beside it. So I will start by writing given, you know that. All right, or you can ignore the given, but you cannot ignore extracted. So given the vector AB to be equal to is a column vector with a component 3, 4. Okay, the vector BC, okay, with the component, okay, 8 what, -2. Okay, the vector PQ, okay, with the component -1, -5. And our last vector, okay, or you can use comma. You know, I've told you that in math, okay, comma could also mean, okay, end. Okay, ST vector with the component, okay, X, what, Y. Okay. Hello, do you see anything wrong with what I've extracted? How I have extracted my information? Do you see anything wrong with what I've written so far? Okay, Prof.
Yes,
Herbert.
please.
Sir, please, yes.
Okay,
Sir,
what?
sir, please, the BC and the PQ, you didn't put the vector signs,
I didn't put what? The arrow on top to indicate the vector. Is
the
that
arrow
right?
on top.
Very good.
Yes,
So
sir.
take notes. So I'm drawing your attention to some of the basic
Mr. Hansen,
errors that you make. Yes, my prof.
please, can you make the question a bit big?
The question
Yes,
you can see.
yes, please.
Hey, so at my age, I have better sight than you. Go me, go me, go me.
Mr. Hartman,
Yes.
Mr. Hartman,
Are you sure it's not clear?
you can just, no, she can just like
Zoom.
zoom into
You
the
can zoom.
screen.
Okay, so you should zoom.
Yeah.
Okay, you get it. Okay. If it's not clear,
Fine.
you have full
Okay, thank
control. So zoom. All right, you are always welcome. All right, so can we move on now? Are you fine now, my professor?
Yes, please.
All right, you just gave me vim that I have good eyesight. Thank you very much. All right, okay,
Now,
okay, so this is what we have. We've extracted. Now we've done all that. So with this one, it means if there is any mark for this, which there will be, you will get a full score because you've extracted perfectly. Even when you are extracting, you should know there is an arrow on top of this, but you ignored. So you extract what you are giving directly. So then you come to A. And I've told you when you are coming to write the A, you shouldn't leave any line unattended to. Okay, so A, what are we dealing with? You can write given or you can ignore the given and come and write ST vector ST. Okay, you are told is equal to what? Vector 2 times vector AB, not vector 2AB. All right, so this is what we have. So what we have here, please take note, is a relation or it contains equal to. So you cannot start your steps with equal to. Those of you who don't know that. If you were dealing with an expression just as we've been dealing with, so I think so far when we are dealing with vectors, then we know you can start with equals. So immediately, whatever that you've written on top, the statement that you extracted contains equal to or any of the inequality signs. You cannot introduce your steps with equal to, but rather the implication sign. Take note. Okay. In the same way, if whatever that you extracted did not contain equal to or any of the inequality sign, you cannot use the implication sign. You are really supposed to use the equal to introduce your steps. Please, am I clear enough, my professors, especially the new ones? Am I clear enough?
Yes, please.
Okay, very good. Now, do we know ST, the vector ST? Yes, we know, and that is XY. This is equal to twice. Okay, the vector AB, do we know AB? Yes, we know. Okay, AB vector is what? 3, 4. My professors, I hope you are following.
So, sir, please, I don't.
Hello, Prophet Ura. What did you say? Prophet Ura, are you there?
Sir, please, the solution. I don't like.
You don't like the solution. You are not following. Is that what you said, my prof? Oh, please respond. Okay, quickly. Then let me see how best I can address your situation.
She's talking about you. Please, I get it.
You get it now. Okay, welcome back.
Yes. Thank you.
Okay, so this will give us, this one is just xy, which we can choose not to write again anyway, because if you come and write equal to here, we know that what you have here will still be xy, but I'm going to write it, okay, so going forward, maybe I might change it. So this is going to give us the same vector xy, okay, will be equal to, we come and work on this. So we know we are multiplying the scalar and a vector. So each component must be multiplied by the scalar. So we are going to get 2 times 3, which we do mentally 6, 2 times 4, which we do mentally 8. You write it there. So just as we did before we came here. So here we can say that, therefore, we are asked to find the values of x and y. So x will be equal to, remember, the corresponding component. Hey, Ebra, are you here?
Yes.
Hey, are you sure?
Yes.
So what is making you too excited?
My connection is not well, and then my bestie just came to see me. So, like,
Aha, so you were just caught. Okay,
yeah,
I
like,
almost in here. So tell your bestie that you are serious now. Okay,
you're okay.
so you will deal with him or her later.
Okay.
Okay, all right. But turn off your audio. Okay, so
Okay.
that you are not caught off guard again. All right. Okay, so we are drawing our conclusion. At this point, because they are equal, corresponding component must be equal. So you get what? X should be equal to 6, and okay, Y should be equal to what? 8. And remember, from here up to the last, we shouldn't leave any line unattended to. The fact that you have space here, you see, I'm not writing in lines, doesn't mean I left what? A line there. Please take note. You only leave a line when you are moving from a sub question to another sub question. Otherwise, any line must be used. Is my point well made?
Yes.
Okay, and once again, especially those who have joined us for or maybe this vacation and I haven't told you this. Anytime questions are asked and you are asked to find the values of this and that, don't conclude by saying therefore the values of this or no. Just write, okay, write therefore, then state the variable that you have, the write it value, okay, and the other variable. So if we're asked to find the value of x, just write therefore x is equal to a stated value. Then come and write therefore the value of x is no. X is equal to, so this is a value. That's my point. Okay, Prof. Ama,
So why couldn't you just conclude at the last thing?
here,
Yes.
no, if you end here, okay, you've not given me the values of x and y. You get the point?
No.
You don't get it. Okay, so this is it. You were asked whatever that you have here. It means the person who is going to now, anybody who thinks that the person should be well versed in math before the person will know that x is equal to 6 and y is equal to 8.
Okay.
Yes, the person should be aware of equal vectors before the person can use that to get the values of x and y. You get my point?
Yes.
So you were asked to find the values of x and y. So your conclusion should have the x values explicit and the y value explicitly stated as well.
Okay.
All right. Okay. So on that note, can we move on to the second one?
Yes, please.
Okay. All right. So, or I will skip the second one, then we'll do the third one. You will try the second one. Is that okay, Deji?
Please, no, do the second one.
Who is that? Abelema, were you the one?
Yes,
And that's
please.
why you said we only do the ones in red ourselves.
This one.
Yes, so please, we beg.
Oh, you don't have to beg. Oh. Me, I'm not that expensive. Momo me. Allow cash out. Okay, so let's move on. No problem at all. Okay, if you want us to do it, okay, we'll do it. Only that I was of the opinion that if you're able to do this, you should be able to do this. You get it? So I was going to handle the more difficult ones so that you try this one. But maybe you've seen me and you know that I have a big head. So every load I can carry. So no problem. I will carry this load. So let's move on. Okay, so we are going to get to the B. When you are moving from A to B, you leave a line, at least a line, maximum 2 lines. So with this one too, I cannot draw my conclusion straight away because I was not asked to find, okay, I was asked to find X and Y. So that's where my conclusion will be. When we're doing the probability, you know that I'll start by writing therefore probability because I will be finding exactly what was in terms of the probability. But here I cannot start with therefore. So please take note, know the distinction. So I can write given or choose not to write given, but extract whatever that I'm supposed to use to find the values of x and y. And I'm supposed to use 2 twice the vector st, okay, is equal to, okay, the vector ab. Okay, so this is an equation, okay, or a relation sort of. Okay, so let me see. Can I start with equal to? Can I introduce
No,
my steps with equal to?
no, please.
No, you start with implication. Now you know. So take notes, okay, of that. So this implies that the vector 2 st, what is st? St, okay, would be x what y. Okay, and that should be equal to the vector ab, and ab is our 3, 4. My professors, I hope you are following.
Yes, please.
Okay, so here,
Mr.
before,
Hoffman,
yes, my prof, are you there? Prof. Abilima, Oh, please unmute and respond. Are you with me? You mentioned my name. You scared me the way you mentioned my name. I think it's a network. Okay, so maybe later she can watch the girl when she comes back and she wants us to go back. And possibly I will do that. So with this one, before you can equate, okay, make sure your let me see, somebody sent a message or the person has deleted. Okay, maybe the person has change his or her mind. Okay, so we said 2st. What is st? You know the vector st is given xy. So you substitute. Vector ab is also given is 3, 4. So you substitute. So after writing this, the next step is just substitution. and everyone should be able to do that. Okay, so at this point, I said before you can equate, make sure that your x component and your y component, okay, explicit. The coefficient of your expression here, your vector here is 1, okay, or minus 1, or usually we say it's 1. The coefficient of your vector here is also 1 before you can compare. All right. Okay. So now I know that to make my coefficient here 1, I need to push in the scalar. So that will give me 2 times x, which will give me 2x, 2 times y, which will give us 2y, and that should be equal to 3, 4. My professors, I hope you are following.
Yes.
Okay, very good. Now we are asked to find the values of x and what and y. Okay, so what do? We know, okay, by equality of vectors, okay, so I can write that this implies that, okay, 2x should be equal to 3, and that is my x component should be the same, and my y component should also be the same. So, and 2y should be equal to what? 4. My professors, are you with me?
E.
Okay, so we are looking for x and y, not 2x and 2y. So what do? We come and solve for x here in this equation. So we write it again before we divide by, okay, 2. So over 2 over 2. Then this one, 2, we solve below it. We write it again before you divide. Don't divide straight away by the 2. Okay, so over 2 over 2. Okay, so this will give us x is equal to, okay, 3 on 2. Okay, then here you get y to be equal to what? 2. All correct. Okay,
Yes.
so remember we've not drawn our conclusion yet, so we are going to draw our conclusion. So I write, therefore, okay, x is equal to, okay, 3 on 2, or, oh, sorry, and, not or, and y is equal to, because the connector here is and, y is equal to 2. Do you see anything wrong with my conclusion based on a certain advice that you've been given? My professors, are you with me?
Yes.
Uh-huh. Do you see anything wrong with my conclusion? Okay, if not, then we move on. Based on a certain advice that we've been given since I started teaching you in class 1. All right. Remember, I told you to avoid concluding with which type of fraction unless otherwise stated.
Improper fraction.
Okay, so I said avoid concluding with an improper fraction. Take notes. Okay, don't forget some of these basic things and lose, okay, certain important mark. So it means in your conclusion, you have to change it to base number. So it's 1 whole number, 1 over 2. I hope I'm clear now.
Yes.
Okay, very good. So that will be it for the B. So those of you who said I should do the B, I guess you are now happy.
Yes.
Okay, so we are going to look at what the C. The C will be the last one that we'll do together. Okay, then maybe the D. If you are able to do the B, sorry, the C, you should be able to do the D and therefore the C if it comes, okay, to you as an assignment. Is that okay with you? I want us to
Yes.
cover, okay, more. Okay, other than that, if that's the case, the next time I'll reduce the number of questions here. Okay, because I've realized that you always want us to do all the questions. Okay, all right. Okay, so let's move on. Okay, so what do we do? C. Okay, so when I'm moving from B to C, I'm moving from a sub question to another sub question. So I leave a line. So I'm looking at C. Okay, C, what have I been given? I've been given half. Okay, vector BC. So this one you have 3 vectors. Okay, plus, okay, vector PQ. Okay, then is equal to vector ST. All right. Okay, there should be a space. The way I've written it is like there is no space. I've told you I'm not using lines. So once I've told you the right thing, you do it. This also contains the statement that you've extracted here contains equal to, so you cannot start with equal to. Okay, it's not an expression to start your steps with equal to. So you write implication or you can ignore. Okay, so it will be half, you go and substitute. What is the vector BC? The vector BC is 8, -2. So 8, -2. Okay, then plus the vector PQ. What is the vector PQ? It's -1, -5. Okay, it's equal to the vector is ST, our usual ST, which is XY. All correct? My professors, are we all fine?
Yes.
Okay, good. So at this point, we are more than good to go. So what do? We are going to look at, okay, we are going to look at how to deal with this one first. Remember, I said before you can equate, make sure you have a single vector here with its coefficient being 1, another single vector here with its coefficient being 1. This side, okay, satisfy that condition, but this side does not. So we need to go and work on this side. So we have a scalar multiplying a vector, so we are going to deal with that one, okay, which will give us, okay, 8/2, which is half times what, 8, and that will give us what, 4. And half times -2 will give us what? Okay, -1. Am I right?
Yes.
Okay, then plus this one, you don't do anything to it. So -1, -5. So this side, we are just performing algebra, which we know how to deal with it. Okay, because we were taught in the previous lesson. Okay, so at this point, okay, we know how to write this as a single vector by using algebra. So we are going to sum these two vectors. So it will be 4 plus -1, which will give us what? Plus 3. Then -1 plus -5, and that will give us minus what, 6. Okay, and that should be equal to xy. Afa.
Yes.
Okay, so at this point, we are in a comfortable lead. We can draw our conclusion because we can compare. When you compare straight away, you get the values of all your x and y. So you can draw your conclusion there. Therefore, okay, x is equal to what, 3, or you can write 3 is equal to x. I usually want to write the variable first. And, okay, y is equal to what, -6. Sapa.
Yes.
Okay, so as simple as that. So we are done with what? Okay, these two questions, okay, related to the use of what? Equality of vectors or equal vectors. Any questions at this point? Hello?
Okay.
Okay, so we are fine. Okay, so let me see what we have in our, okay, so I guess I am going to, okay, pause here, give you your water break. When you come back, then we continue with the parallel, okay, vectors. Okay, all right. So your water break starts now. Okay, so welcome back from the water break. Okay, we are still on types of vectors, so we are going to look at our next type, which will be parallel vectors. So, and I read, two or more vectors are said to be parallel if they have the same or opposite direction, regardless of their magnitude. Same or opposite direction, regardless of their magnitude. Okay, so usually we'll say that in simple terms. Okay, two vectors are parallel when one is a scalar multiple of the other. When one is a scalar multiple of the other. Okay, so remember when we were looking at equal vectors, we said for your vectors to be equal, the magnitude should be the same and they should also be in the same direction. Okay, so when it comes to parallel vectors, we are not interested in the direction. They could be in the same direction, they could be in opposite directions, okay, and still be what, parallel, provided, okay, one is a scalar multiple of the other. But for equal vector, they should strictly be in the same direction. So for two or more vectors to be equal, they should be in the same direction and they should have the same magnitude. Is my point well made, my professors?
Yes.
Okay, so
Yes.
now in terms of computation, okay, I'm going to read this. Okay, and it contains some of what I just said. If one vector is a scalar multiple of another, they are considered to be parallel. That is, if I have vector AB, and you know in math this represents this symbol, okay, that you have here is for parallel. So if vector AB is parallel to vector CD, then vector AB should be equal to, okay, K times the vector CD. So we know that K, remember, is a scale factor. Remember when we did the product, multiplying the vector by a scalar. So K here will be a scalar. So it means AB is a scalar multiple of what? CD. Take note of that. Or the vector CD should be equal to a scalar multiple of what? The vector AB, where K is what? A scalar. Okay, so please take, so they should be, the two vectors should be scalar multiples of each other, as simple as that. One vector is supposed to be bigger than the other vector. Okay, but how big? Okay, but what is important is one vector should be bigger than another vector, but there should be a common scale factor, a common K. Okay, with respect to your X component and your Y component, and you will soon know exactly what I'm talking about. Okay, better. So quickly, let's go and look at the following situation without wasting time. Okay, seems I'm a little behind schedule. All right, so let's look at the following worked example. Determine whether or not the following pairs of vectors are parallel. Okay, I think they shouldn't have been here. Are parallel or not? Okay, should have been. Once you said whether or not, they shouldn't be. Okay, this. Or it should be determine whether the following vectors are parallel or not. They shouldn't be or not here. So I will do the editing, okay, later. All right. Okay, so now this is it. As usual, you know, once you read question, you check to know or underline, check whether you have any salient part to be underlined. So what am I supposed to? I need to determine whether the vectors are parallel or not. So indirectly. Okay. Then, is there anything else for me to underline? No. So the first thing that I write is solution. After solution, I will extract all that I need to extract, okay, to deal with. So here, there is no general information to extract. Unlike the previous one, you saw that with this one, there was a general information here before your sub questions. Okay, but with this one, no, there is no general information. When you come here, this information here is particular to A. Information here is particular to question B and what have you. So there is no general information for me to extract. So I come straight away to A. Okay, so A, what am I giving? I'm going to extract. So I've been given, if you like, so I'm going to write given. But you can say that the previously I didn't write, just to vary. You can choose not to, but you need to extract this as always. So vector AB, okay, is equal to what? The column from 2 or 3. And you know, okay, vector CD. So these are the two vectors that you want to determine whether they are parallel or not. Okay, so which is what? 6, 9. Okay, so you've extracted. Okay, now what is the condition for two vectors to be, okay, parallel? Do I know the algebraic condition? Yes, I do know. So this is what I'm going to state. I know my foundation. Okay, Prof. Amenya.
Please, is it possible for you to go back and explain the power vector, because my network just disconnected and I wasn't
Okay, don't
aware.
worry. I will get this. I will explain it here. This is the first example. So all that
Okay,
you have in the, I will say it here. So you are covered. Okay, don't
okay,
worry much.
okay, thank you.
All right, you are welcome. All right. So at this point, you know, you are going to state your condition for two vectors to be parallel. Okay, for two vectors to be parallel. So I'm looking at vector AB to be parallel to vector CD. So I'm going to state my condition. So I will write for, okay, vector AB, okay, to be parallel to vector CD. What is the condition? One is supposed to be a scalar multiple of the other. One is supposed to be a scalar multiple of the other. So I can write vector AB, okay, should be equal to K, okay, times what? Vector CD. I can choose not to write that, put it that in brackets because it's the same. So K times vector CD. So I'm stating the condition which you know from the previous slide. Or somebody could have done CD should be equal to KAB. It's the same thing. Is my point well made?
Yes.
Okay,
Mr.
so
Akma, please, is it B on Q or B on 7?
Which one?
CD is equal to,
This one.
yes,
Prof. Harris,
yes, Mr. Happy.
you want to tell me that my handwriting is not legible? I won't mind you. Okay, so this is it. Remember, okay, you are extracting it from here. So it's 6 what 9.
Okay.
Okay, so you are extracting from here. So you should be able to. I know I've seen your plans all. So well noted. My handwriting is not legible. So let's move on. Okay, all right. So this is what we have. So we are going to build on this. So if you are able to write vector AB to be equal to a number times another vector, then you are okay. So this is what we are going to do. So I can write this implies that, okay, because what I'm going to work on here, the condition that I've stated here contains equal to. What is your vector AB? It's 3, 2. Am I right? Sorry, 2, 3. Okay, and that is equal to, are you with me? What is your vector CD? Look at the way I'm going to do the presentation. So please take notes. Okay, I'm going to write the K. Okay, CD. What is your CD?
6, 9.
Okay, 6, 9. So this is what I'm going to do. Okay, so very soon, don't write. If you are writing, don't write. I will explain it in the first example. So I will help you to deal with it maturely going forward. Okay, so now, okay, I will check if I can write, okay, what I have here. Okay, I can bring a constant out so that whatever I have inside here, okay, will be the same as this. By that, this is what I mean. Can I bring a number out here so that this will be 2 and this will be 3? Which number can I bring out?
3.
3. So I can write this one as 3 into what? Okay, 2 times what? So 2, 3. I hope you are with me. So it means this vector AB that I have here, I've been able to write it as what? 3 times, okay, this vector. Okay, to get this. I would take another route, and I believe that will be the route that you will go. Okay, so this is it. So because I've been able to write this one as what? A scalar times that, then I'm good to go. But usually this will be my advice. Okay, this will be my advice. Always look for the bigger vector. And when in vectors, okay, we use the magnitude to determine its size, the size of what a vector, how big the vector will be. Yeah, and the magnitude will depend on the numbers here, your components. So if I look at this is, okay, Prof. Karen, okay, I want to land. When I land, then you come in, you put up your hand again, okay. I'm making a very important point. Then you come again. Okay, thanks for your understanding. Okay, so I said the way I am going to deal with it going forward, or even with this one, that alternative approach, what I would entreat you to do is when the vectors are given, okay, first of all, check which of the vectors is bigger in terms of magnitude. So it will be the vectors, okay, or the vector with what bigger values in terms of what the components. So if I look at these two vectors, obviously I can see that this vector here, the vector CD, is bigger than the vector AB. So when I have that, then what I will do is I will always write my statement as what my bigger vector should be equal to K times my smaller vector. This time, right, you can see that the way I started, I wrote my smaller vector is equal to K times my bigger vector. And it shouldn't be so. Okay, I'm not, no, should I say for lack of, I'm not trying to say that it shouldn't be so. Meaning, I'm trying to say that don't do it that way. Okay, the other way will be better. So if that is the case, then this is how I'm going to go. I'm going to clear the whole of that and teach you, okay, the best way to deal with it. So I will clear this vector, and swap now. So my professors, are you with me?
Yes.
Okay, so my bigger vector is CD. And this is your bigger vector that you obtain by multiplying, okay, your smaller vector by a scalar. Because we want to avoid our scalar being a fraction. That's the more reason why we are writing it here. So it will be K times the vector AB. Okay, so on this note, then it means this is what I'm going to do again. I'm going to clear this. Please listen and listen. Okay, so I will clear this and that. Okay, so this and this. So this is what I'm going to do. So that it will come, the relation will come out clearly. So what is your vector CD? CD is 9. Okay, what? 9, 6, 9. What is happening? I guess I'm also getting hungry. All right. So what do we have? 6, 9, 6, 9. Okay, so this is your vector CD. Are you able to write, okay, your vector, okay, what do you call it? CD to be equal to K times your vector AB. And what is your vector AB? Your vector AB is for 2 times 3. Is that clear? Is that okay?
Yes.
Okay, so now let's see. Okay, am I able to get a number that if I multiply these two, I multiply it by 2, I will get 6. And I multiply it by that same number, I multiply that by 3, I will get 9. And obviously you will get this. So it means what I have here, I now know my K. So my K will be equal to, oops, did I pick the eraser? Okay, so this will be 3. I know that I can multiply this by 3, get what 6, this also by 3 and get this. So that will give me 2, then 3 here. So you can see that indirectly, my vector CD is equal to a K times the vector what? AB. Can you see that? And this only that this time that you know your K to be 3. So I've been able to write my vector CD to be a scalar multiple of what? The vector AB. Is my point well made?
Yeah.
Okay, so at this point, I can comfortably say that therefore, okay, my vector AB, because we're asked to determine whether they are parallel or not. Okay, it's parallel to the vector CD. So your conclusion, you can back it with your reason. Okay, since, okay, your vector AB, so I can write the vector CD, okay, is equal to K, your vector AB. Okay, or if you like, you can write, okay, your is equal to 3 times your vector AB. So let me be more definite. Okay, so that you can get it. Okay, so I'm coming, Prof. Amma, I'm coming. I'll give you an alternative way, and that will be the way that maybe I can. Is it 2 or 3? What is happening? Okay, I've started exhibiting symptoms. Okay, all right. So now this will be 3AB because it's a scalar multiple of that. Okay, Prof. Amma, and somebody's hand was up, then I said, let me land. I will give you the opportunity to talk. But let me give that person the opportunity before Amma comes in. Okay, so go
Okay.
ahead. Mhm. Unfortunately, I couldn't make out the person. So if you are the one, please, okay, I've given you the floor.
Mr. Hackman, please, I don't understand how you got the 3
Out.
and the K, like, yeah, the 3.
The 3. Okay,
Yeah.
so you are looking for a number that you can multiply by, okay, you can multiply it by 2 to get 6 here, and multiply it by 3 to get what? 9. Is that okay?
Yes, please.
Okay, so that you can bring that common number out. So if you get it, so usually I would say that if you want to just take this one, divide by 2, okay, take this one also divide by 3. If you get that constant, then it means, okay, your K that you have there will be that value that you had there. That's also another smart way.
Yes, please.
You get it?
Yes, please.
Okay, Prof. Amma.
Mr. Hackman, please,
Mhm,
see if written for vector AB to be parallel to vector CD.
mhm.
Then you can put the arrangement here. CD, vector CD is equal to K, vector AB. So whether you write the AB, the vector AB at the right side, nothing will change, right?
Nothing will change.
Can
Okay, if A is equal to B, B is equal to A. If line A is parallel to B, line B is parallel to A. You know that even in the definition, I said
but
it
say,
indirectly.
when
Let me go back a little. You can see that I made the
Okay,
same
so
point
see.
here.
So when
Can you
you
see it
make
here? So it doesn't really matter your arrangement. What is
yes,
important is one is a scalar multiple of the other. Okay, so let's go here. Ask a question if maybe you are not fully
uh-huh.
satisfied.
Yes, said I see when we did this in this way, we got 3 as a whole number.
Mhm.
But when you make A B the subject rather,
You
A
get a
will be
fraction.
a
No, you remember I
and
said
yes,
it. Please, did you hear that? Because I wanted us to avoid fraction. That's the more reason I always want you to have your bigger one here. Did you hear I said that? Did you hear me say that? Or I didn't? Did I say it or I didn't? I remember saying
Please.
it along the line, didn't I?
Yes, you did.
I did. Because I want us to avoid fraction. That's the more reason why I said look for the bigger vector. You get it now, Prof. Amma. So that your scale factor will always be positive. It will always be an integer, not a fraction. It could be a negative whole number or a positive whole number, sort of. Prof. Amma, are you fine? Okay, however, I'm going to teach you another way. With this one, you have to be looking for, okay, whether you get a common, okay, constant that you can bring out to be your scalar. Okay, but with the other one, this is what you are supposed to do. So alternative approach. Okay, alternative approach. Alt. Okay, and
Sir,
that
please
oh, Prof. Walali, I think your hand was up. Forgive me.
yes, please. So please, see in variation, K is also constant.
Okay, it's
So
the
here,
constant of variation.
yes, and then so here in vectors, K here too is also representing constant, but can the K here change? So a
No,
different letter also represents a vector.
can it
We
change
also
like how? I
represent
don't
it.
get it.
So in variations, K
Mm-hmm.
is representing constants.
Mm-hmm.
In vectors here too, K is representing constant, but I'm
Yeah.
asking,
Mm-hmm.
in vectors, can the K be something else to represent the constants? Like can K be A to represent a constant?
Oh, you can see that usually in math, okay, we use K to represent a constant. It can be A, it can be B. Okay, that's why you know this, you usually use it in our normal everyday language. Okay, this one is a K, meaning definitely it will happen. It's a constant. Or you've not been using that. You've not been saying that. Just wait there, K.
No, please.
Oh, really? Okay, how many of you have heard this or someone say this? Just this one, there is K.
Yes, please.
You get it? You also know this at any time T. It's a normal everyday, math language. Okay, but my point is, in math, usually, okay, whenever you see the small k, we use that to represent what a scalar. So k will be a scalar. Okay, only that it's a constant, but okay, we don't call it a constant anyway. Okay, but we call it a scalar in this situation. Okay, but every scalar is a constant. It's not what a variable. So you can represent it by maybe A. And so you can say that vector CD is equal to A vector AB, small a vector AB. Only that you should know that your A is your constant that you are looking for. That's all. Pafolali, do you get it?
Yes, please.
Okay,
Thank you.
you are welcome. All right, so this is it. Let's look at the alternative approach. And I will ask you, though I will know the answer that the one that you go for. I will ask you which one do you think you can easily relate. Okay, so this is it. You still need to know the condition. With this, what I'm going to do, it doesn't really matter which one you start with. But again, I will advise, okay, start with what? The bigger, okay, vector whenever you are defining your parallel condition. So in this case, alternative method, you still extract. Then you come and write for, okay, vector AB, you know the condition, to be parallel to vector CD. Okay, then you know, so comma. you should know that your vector, so let's pick the bigger vector. Okay, so the bigger vector is what? CD. Again, and I said it doesn't really matter. We'll do the other one too. My point will still be made. Okay, vector CD should be equal to a k small k times the vector AB. Don't forget your arrows on top. So this is what you can see that whatever you form here, we are dealing with equality of what? Of vectors. This vector is equal to this vector. Do you agree? So now we are dealing with equality of vectors. We are going to look at it from the equality of vector perspective that we just came from. So what do we do? I'll write this implies that what is my vector AB? Sorry, CD, forget. CD is for 6, 9. So this implies that the vector 6, 9, okay, will be equal to, I will still use my K. Okay, then my vector AB, AB is what? AB is 2, 3. My professors, I hope you are following.
Yes, please.
Okay, so this
So
is,
Mr. Akma,
yes.
is it like I want to know if it is okay to also write since, like, I don't know, is it okay to write, not that is it okay, but like, is it that you're writing it there, or we can also write since, because I don't understand.
Since, which sense are you talking about?
You're putting there for AB, and then yeah, you're putting since
No,
C.
read this.
No, I'm talking about the since there.
No, it's okay. I said read it. I want to see if you can see it.
Oh, Mr. Akma, I can see it.
Oh no, you just read it. You know why I'm asking you to read it. Okay.
Okay.
Oh, just simple instruction. Read it. So you want me to go up. Hey, I respect me. All right. Okay, so read it and let's go.
A, B, and then Mr. Akma, what is that?
You forgive me. You said you can read it. You see, that's the more reason why I realized that what you have there, you cannot read it to understand it. So sometimes don't downplay my experience. Okay, so this is it. Okay, so we said therefore. Okay, what were you asked to determine? You were asked to determine whether the vectors are parallel. Is that not it?
Yes.
So once you go through all that you've gone through, you need to come and draw your conclusion whether they are parallel or not. Is that not it?
Yes.
So we are now drawing our conclusion. So therefore, the vector AB is parallel to vector CD. You get it?
Okay.
Then the sense here, you are just backing your conclusion with the reason for us to know that it wasn't a guesswork or it wasn't a corporate work. You know what you are doing.
Okay.
You get
So
it?
we can write it.
So sense, so you are just backing your conclusion with the reason.
Okay.
Since vector CD is a scalar multiple of vector AB, and the scalar is what? Is 3. And you can even write K there, because indirectly we can see that the K is 3.
Okay.
You see it?
Yes, please.
Okay, so next time if I give you direct instruction, just obey. It's for your own good, okay?
Yes, please.
Okay, all right. Prof. Ameya,
So say,
Olali,
please, if it's not parallel, how are we going? Yes, please. So please, if it's not parallel, how are we going to
okay,
write
so
it, or I should wait?
wait now. Well, Professor, you know I will deal with all situations. Okay. All right, okay, so now here we go. So very soon you will know we are looking at the alternative method. Okay, all right. You know I will never give you the short end of the stick. I'll make sure you get all that you are supposed to get. Only that if I'm giving you complex questions which involve more work, then I do so. But all the basic information you'll be provided with. So here now you are dealing with what? What do you call it? Equal vectors. Okay, so you are not going to find any, so we continue. So I will just write 6, 9. Vector 6, 9 should be equal to push this one in. So to be 2k, okay, 3k. Please, are you following?
Yes.
Yes.
Okay, so at this point, you can see the equality of vectors we can equate. So when you equate and you solve for your k, the k in the s component and the k, okay, resulting from solving the y component equation, if they give you the same value, then it means the vectors are parallel. If you get distinct values, then it means they are not parallel. It means your k is not a k. Your k should give you one value. That's why it's a constant. It doesn't vary. So if it gives you more than one value, then it means it's not a k. You get my point. It's not actually a k.
Please come again.
Okay, so that is it. I'll continue. So at this point, what do? We know we are going to solve and find the value of k. So we are going to get with this one. We found the value of k mentally. That's why we got this one to be 3. But with this one, we are not going to do that mentally. Okay, so we are going to get what? This implies that, okay, 2k is equal to 6. Somebody can write 6 is equal to 2k is the same thing. I want to write a variable term on this side. Okay, and the other one to give us 3k is equal to 9. I hope you are following, Prof. Olali especially.
Yes, please.
Okay, so let's come and solve for our k. So 2k is equal to 6 over 2 over 2. So your k is equal to what? 3 here. Let's come and solve for the k here. 3k is equal to 9 over 3 over 3. So k is also equal to what? Is also equal to 3. So you can see that irrespective of the components that we use to form the equation, we have the same values for k after solving for k. So it means your k indeed is a k, it's a constant. It doesn't change. Okay, it's the same. So at this point, you are more than comfortable and convinced that the two vectors are what? Parallel. So we can say that therefore, your vector AB, okay, is parallel to the vector CG. And I said again, if you want to, what do you call it? Attach a reason, which usually I advise you do, you attach. So since your vector AB, you can still write vector AB, okay, is equal to k times, because your k indeed was a k, so you can now write, okay, that as CG. Back it to your reason. Your condition, your premise here was satisfied. Okay, or if you want to write this one here, you can equally write it there. Point well made.
Yes.
So you saw that when I was explaining this, how to get your k, especially when there was a follow-up question. Okay, I said if you want to get your k, divide, okay, this one by 2. Divide this also by 3. And that's what we did here. Can you see that? That's what we did here. We divided, okay, after equating, you realize that we divided, okay, this one by 2 to get the k, this one by 3 to get the k. And the k gave us the same value. So we can say that the k will be 3. It's a constant. Okay, so from place. Oh, your line. From place and your line. Please, okay, if you can type, okay, type and send it to me via chat, because your line breaks and I'm not able to, okay, relate with whatever that you are saying. I'm sorry, but so come again. Okay, Prof. Sam.
Mr. Hackman, please, can you explain the conclusion as to why vector AB is equal to KCD
Okay.
and not like CD?
Okay, all right. So, you know, okay, if, let me say, let me use this way. If I say that x is equal to, okay, maybe 4k, let me use 3k or 3y. Okay, x is equal to 3y. I can also say that the 3 here is a constant. I can also say that y is equal to 1 over 3x. And this will also be a k. So irrespective of which direction that you go, the 1 is always being multiplied by a constant. So that's why I said it doesn't really matter how you state. Only that in terms of how to bring out your k here, okay, for it not to be a fraction, it is better you start with a bigger, okay, vector. You state the bigger vector here. But it doesn't really matter. If this one, you need to multiply this one by, okay, your AB by a whole number to get what your bigger vector, then it means if you have what your smaller vector and you want to get the other one, you need to multiply it by what a fraction. I don't know if you get my point. So my point basically is that anytime, okay, I write 3 x is equal to 3y. I can also write this as y is equal to 3x. So this one is x is equal to ky. Is this one also the same as y is equal to kx? Only that the k's will change. One will be a fraction, one will be a whole number. But it's still a k.
Thank
Apa,
you.
you get it right.
Yes, please.
So any one that you take will go. Only that one will be a fraction, one will be a whole number, sort of. Okay, so Prof. Amma,
Is that one, please? I don't get you. Is
you
that
didn't
one?
get
See,
which
you
one?
said. Let me show you. You said if x is equal to 3y, that means y will be the inverse of x. So here, vector CD is equal to 3 vector A.
Did I
So
say
that means
y
if
will be the
vector
inverse
A,
of x?
no, y will be equal to the inverse of 3x.
Okay.
So since vector CD is equal to 3 times of vector A, that means vector A will be equal to the inverse of 3
So it will be one
of
third of.
vector C.
It will be one third
Yes,
of. Mhm.
yes, instead of CD. So see your second conclusion. If you think since vector A is equal to K vector CD
Mhm.
instead of 1 over K.
Oh no, you see, are you talking about this?
Yes.
No, you can see that when I use the k, okay, when I use the k here that I said I stated it here, I didn't state its actual value. So if I've stated what 3 times it, then it will be wrong. You get my point. All that you want to know that there one is a scalar multiple of the other, okay, or they will be scalar multiple of each other. I hope you get my point. So if I come and write the k here, I didn't state the value of k. Okay, if I stated the value of k as 3, then it would be wrong. Only that in this situation, I know that because I started with a CD is equal to KAB, I know that the k that I have here will be 1 over 3, not 3. But if I started by writing it this way, the way I quoted it here to find my k, then in this case, I will know that my k will be exactly the k that I have here. So if that is what is causing the problem, okay, in any case, I wrote it. Okay, so I can clear it and write the other one there because I thought maybe your foundation is strong, so you appreciate it. I didn't bother, okay, reflecting exactly what you are. So CD is equal to your condition here is satisfied. So KAB. So am I free now?
Wait, Mr. Akman, last one. Mr.
Okay.
Akman, so since you are saying it doesn't matter, but in our solution, we have already defined K to be 3. So the marker will know that K is 3. Or
Okay, so the marker will know that K is 3 when you are dealing with this equation because you can see that there was a preamble. So if this
yes.
was what you concluded with, then the marker should know that, okay, it's supposed to be a 3. But if it was the other way around, then the marker will know that this time around you make A be the subject. So it would rather be 1 over KCD. And your K will still
Okay.
be 3. You get it?
Yes.
Okay, all right. Sapa.
Yes.
Okay, all right. So ask questions. I like it when you ask questions. Okay, anyway. Okay, so Blaze is fine now. Okay, there was another hand up. Karen, your hand was up. It seems I saw your hand up.
Yeah, I wanted to ask the same question.
Okay, so it's been addressed. All right. So if that's the case, then let me clear what we have there, then go and continue. Let's see. Hey, let me look at the time. Oops, I have so at least let me finish with the parallel. Okay, so let's see if you can do one more. Okay. All right. And take note, usually these kind of questions they come in objectives. So objective, immediately you get the K to be the same. You will know that they are parallel, so you go for the right one. Okay, you don't come and do this. I hope you get my point. But if it comes and I'm doing it just because in case it comes in the subjective, you know how to carry out your presentation. For objective, you can even look at it just as I was able to for us to see that one is a scalar multiple of the other, and you just pick. So which of the following pairs of vectors are parallel? You should know how to bring that one out. Okay, just by looking at them. Okay, all right. Or you go this approach. So now let's look at, okay, Prof. Abelema.
Mr. Hakman,
Yes, my Prof.
please, I want to ask you something.
Okay, go ahead.
So, you see, like, although, if you want the vectors to be scalar multiples of each other,
Mm-hmm.
yes, is it only the like, if I want, like, I get a question, right?
Mm-hmm.
And maybe, how do I say it? The constant is the same, but the values in the column are different. Doesn't mean that they are not like parallel.
The values in which so are different as in.
Yeah, so maybe it's not the same as okay, let's say like maybe this 2 is negative and this 3 is negative. Doesn't mean they are not parallel.
Okay, so it depends on whatever you were dealing with. Remember, I said before you can say that they are parallel, you should be able to bring out a constant. Okay, a particular value that when you multiply, okay, the value, whatever that we had here, okay, should be the same as one of the vectors and it should be your other vector because you've stated one of the vectors here. And you want to tell us that, okay, this vector contains the other vector by multiplying it by a constant. So if you are able to bring something out for you to see the other vector directly here. So if let's say this was negative, like you said, this was negative, then it means yes, I can still make this one the same as my AB 2, 3. So it means I rather have to bring out negative 3. So I'll bring out negative so that this will be, you get the point.
Yeah, okay, get it.
You get me now.
Yeah, I absolutely get it.
Okay, all right. So that's why I said, ask your questions, no matter what. Okay, God will give me ways that I can explain for you to understand. So ask your questions. Okay, all right. Okay, so now because anytime we start a lesson, we pray before we start. So I know God is in control. All right. Okay, so at this point, okay, we are going to look at the B. Our time is almost up, but we have to look at a situation where we wouldn't be able to. So we'll do the B. Let's see how to
Mr.
deal with it.
Hartman,
Yes, my prof.
Can you skip B and go to C?
I should go to C. You see, I wanted to skip
Yeah,
the
because
B.
B is
I,
similar
I, I
to A.
wanted to skip the B, but I was afraid because of what happened to me initially. Okay, so if you are lobbying that I should skip the B, then okay, I'm a humble servant. I'm skipping. Okay,
Oh,
about
thank
your
you, thank
behest.
you.
Okay, so I'm skipping. Only that I'm
So
afraid
please, I think
if they don't come and beat you. Okay, so let's move on. For Falali, if you're able to do the C, you should be able to do this. Okay, you
so
can
please,
try.
I think I'm coming to beat you.
If you are coming to beat me, rather.
Yes,
Oh,
please.
no, me, there, tell me, your
You with
stuff.
her.
Me, I'm just a servant. So you cannot, I was just asked to, so I'm skipping. So if you have any beatings, please
No,
go to
please, please
Abelema.
don't skip.
Okay, don't worry. I'm going to skip for now. I will do it when we have time. Is that okay? So
Okay.
just give me your maximum attention so that you understand. Then there will be less questions for us to look at it later. Okay. All right. So, hey, so this is what we are going to do. So, as usual, giving, or you can choose not to write the giving, but we'll extract the vector. They came in a special form. Okay. So please take notes. I will play on your intelligence a little. So watch exactly what I'm writing. Okay, because it's likely some of you will write it that way. Okay, do you see anything wrong with what I've written?
That's big.
Okay, what is missing?
The tilde.
The tilde. Okay, so tilde. Other than that, what you are dealing with are not vectors. Please take note.
Zetilda.
Very good. Okay, so it's bold. Both. When you are writing it, it should be written in what? In the tilde form. Okay, so now we are going to state our condition. So for okay, your two vectors to be parallel. Now let's look at the two vectors. Which one do you think will have a bigger magnitude? Remember, I said just use the entries, the size of the entries. Neglect the negatives because you will spare. Obviously, it will be the vector A. Are you with me?
The A.
A will be
Please, the A.
vector. Okay, so I'm going to state that, okay, go that same direction. Vector A, okay, is parallel to vector B. Okay, for vector AB to be parallel to vector B, then I should say that vector A, okay, should be a scalar multiple of vector B. Afa.
Yeah.
Okay, and remember I said, okay, now I'm going to advise you to go the equality, okay, angle or perspective route. So solve your resultant equation coming from your premise, the foundation of your argument, your condition. When you get the same values for k, then it means your vectors are parallel, otherwise they are not. So let's go and see. So now I'm going to take this. So this implies that vector A, what is vector A? Minus 4 minus 12.
Minus 4
Okay,
minus
should be
12.
equal to k small k into your vector B, which is 1, okay, 3. So here we know that minus 4 minus 12, okay, should be equal to this times k. So that will give us k. This times k will give us 3k. All correct, my professors?
Yes.
Okay, so this again implies that for these two vectors to be equal, the corresponding components must be equal. So I will get k to be equal to minus 4 here, and okay, minus 12. So let me use 3k because I moved, and 3k, forgive me, let me erase that because I'm writing the terms in k on this side, on to the left. Okay, so 3k should be equal to minus 12. Okay, so here k is already solved for. So let's come and solve for k here. So if you solve for k, I'm skipping, so I shouldn't skip. I'm moving on minus 12, so over 3 over 3. Unfortunately, it has gone into. So I'm going to continue here for lack of space. So k will be equal to minus 4. Do you agree? Hello, do you agree, my professors?
Yes.
Okay, so otherwise yours will come down. Okay, it will be down here, to be down here. You will continue here down. But if it doesn't go there, you can still come and do it here. But rule a line other than it to be considered as a rough way. So if you compare your two values, are they the same? Your two Ks, are they the same? So what does that tell you about what? The two vectors.
They are parallel.
So you come and write, therefore, vector A, okay, or A tilde is parallel to B tilde, since A tilde is equal to K B tilde. As simple as that. Okay, so now we are going back to the B. Is my point well made?
Yes,
Hello, can we move on to the B?
Yes.
Okay, okay, so B, those who said we should do the B, I'm coming to do the B. B, you extract, so I'm going to be a little brief. So given you extract what you have there, so given these two vectors, then you come and state your condition for, okay, vector, which one? This one will be the bigger vector. So vector PQ, okay, to be parallel to, okay, vector ST, or ST to be parallel to what vector, okay, PQ. Okay, what's the condition? Your vector PQ should be a scalar multiple of what? Vector ST. My professors, I hope you are following. So again, what do we have? This implies that, okay, we come and take this. What's your vector PQ? Minus 6, 8. Okay, and this should be equal to K. What is your vector ST? Your vector ST is minus 3, 4. Okay, so at this point, what do we do? Okay, we know we are going to get minus 6, 8. Okay, should be equal to this times k, this times k. So to give us minus 3k, then 4k. I hope you are following, my professors. Okay, so at this
Yes.
point, you can now form your two equations, okay, by equating the corresponding component. So I'll write this side first. Negative 3k is equal to negative 6, and okay, 4k is equal to 8. I'll come and solve for mine. So minus 3k again over minus 3 is equal to minus 6 over minus 3. Then this will give me 4k is equal to 8 over 4 over 4. Okay, so this will give us what? K is equal to what here? Positive 2. And K will be equal to what here? Positive 2. So it means I can say that therefore my vector, okay, PQ is parallel towards the vector ST. Okay, since then you know what to do. Okay, you know, you attach this reason here. Now let me pick this. I think this one will not. So that we deal with a situation that the vectors will not be parallel. Then you know how to draw your conclusion. Is that clear?
Yes, please.
Okay, we have about 10 minutes more, so we should be able to do that. So D, okay, what are we giving? We are giving, my professors, are you following? I hope you are following. Am I moving fast? Okay, I'm taking my time to explain. Okay, so the first two, so now if I move fast, you should be able to relate. So because I know I've given you that strong foundation. Okay, so vector CD is equal to 3, okay, 1. Are we good to go? So at this point, what do? We state the condition, our premise, the foundation of our argument. So for, okay, so this time round, I want to go any route. Okay, I don't want to go for which one is bigger, which one is smaller, because you can also do that. So that let's see whether I will get a fraction or what have you. But I think consistency counts. Okay, so let's see. Okay, which one will be bigger? I think this one will be bigger. Is that not it? In terms of magnitude, this one will be bigger. So I will say my vector BC, okay, is parallel to, so for vector BC to be parallel to vector CD, what's the condition? Vector BC, okay, should be equal to K times vector CD. Okay, so now this implies that I'm going to use my premise. So BC, what is BC? BC we all know is -1, -4. Okay, that should be equal to K times your vector CD. CD is what? 3, 1. Echo me. So at this point, we are going to get -1 -4 is equal to, you multiply, so 3K, then K. So you get 3K here, then this time this will be K. I hope you are following my professors. Are you with me?
Yes.
Okay, sure. Okay, so now at this point, we know we equate. So this implies that when we equate, we are going to get 3k is equal to -1. So 3k should be equal to -1. And, okay, k should be equal to -4. So obviously, I know at this point, I'm not going to get the same values for k. But k here is solved for. Here is not solved for. I need to go and solve for the k here so that I can confidently compare. So over 3 over 3. So the k here will be equal to -1 on 3. So 1k is -1 on 3. The other k is -4. So you can see that this time round, we didn't have a constant k. So our k indeed is not a k. I don't know whether you get my point. You get it, okay? So you get the language. So at this point, this is the conclusion. Therefore, you know, okay, your condition, your premise was not satisfied. So the vector CD, sorry, did I say CD? BC vector. Okay, remember, we did this when we did coordinate geometry, those of you who were with us. We said, you know, if it has been positive, it will be parallel to. Okay, if it is equal to, you write equal to. When it's negative, you just cross it. So in the same way, this one you cross it. So meaning it is not parallel to the vector CD. You get the point? No, let me write this one well before somebody will equally. It's supposed to be a diagonal line. Mine is looking like a curve, though it's diagonal. So let me clear this one and write it well. Now, professors, I hope you are following. So
Yes.
this one means BC is parallel to CD, but you know that, because you didn't get the same values of K, you know that BC is not parallel. So not means you cancel the parallel. Then not, then you write since if you want to attach your reason to, you will state this your premise. So let me clear. I think I can still write it here. So since the vector BC, okay, you know it's not equal to K times the vector CD. Sapa, especially
Yes.
Prof. Olali, you wanted us to do okay this situation. So initially you wanted to do
Yes,
the
please.
wind out of my sail. Okay, but I believe we are fine now.
Yes, please, I am.
Sure. Is
Thank
everyone okay, my professors?
Yes.
Yes.
Okay. Okay, so that's it. That I said, remember, take note. With this one, the K is not a constant. In any case, we equated the bigger vector. Someone asked the question behind the scenes, okay, via the chat. There's the bigger vector, you got this. So that's the most one of them you had. If you had the same result, one is a fraction, one is not a fraction. So here they are not scalar multiples of each other. That's all that we need to know. Okay, so that's all. But we know that this is a bigger vector. Okay, between these two, in terms of magnitude, there's a bigger vector because you have 1 squared plus 4 squared, which would be the value there will be bigger than 3 squared plus 1 squared. This will give you 10. However, this will give you 13. So root of 10, root of 13. I hope my point is well made. Or is it root of 13 or root of 17? Because this was 16 plus 1. So 17 is bigger than what? 10. Okay, so this will be a bigger one. Okay, and because you didn't get a value that is the same or same values, that's the more reason why you had this situation. So this is better. Point well made. But I am matured and I would not deal with it this way. Immediately I form my equation, I will straight away come and do this. I will take this one, I will find, immediately I get this, okay, I will come and divide this one by, okay, 3. So that will give me minus 1 over 3. Take notes. Okay, so I will call that. Divide this one also by 1. So that will give me minus 4. So minus 1 over 3 is not the same as minus, okay, 4. So it means I cannot get a particular value for the k. Okay, if you come here, I can equally use the same thing. I will do minus 6 divided by 3, and that will give you, okay, positive 2. I will do 8 divided by 4. That will also give me positive 2. So because I had the same result by dividing the corresponding components, I will know that the k here will be a particular k, one value k. So the vectors will be parallel. You get my gist? You get the point?
Yes.
Okay, so you can equally be smart as well and know the type of vectors that we are dealing with before you even start your presentation. My professors, all correct? Are we all fine?
Yes, please.
Okay, so thank you very much. Once again, okay, please don't leave once again for a very successful class. Okay, and thank you for your attention and for your time. God bless us all.